Okay, in this video we're going to look at some properties or characteristics of polynomials. So let's look at the definition first. Polynomial has the form p of x equal to, and here you have it, a sub n, x to the n, a sub n minus 1, x to the n minus 1, and so on. The a sub n does not equal to 0. And these are in descending powers, so the first term has the highest exponent, and that's considered the degree of the polynomial. Okay, a few things I want to point out before I go into some of the statements that I'm going to look at. So let's look at this. If I have the polynomial, very basic, I'm going to use a y here just for convenience instead of p of x or f of x, and I look at y equal x squared. This is a polynomial of degree 2, has one term. If I were to sketch the graph of this, I would get a little parabola that goes something like this. So it opens like that. 0, 0 would be considered an x-intercept or a 0 of the polynomial. Okay, 0, 0 is a x-intercept, and x equals 0 is considered a 0. Now, this particular graph has what we call one turning point. A turning point is where the graph is going one direction and then it changes. So in this case it's going down and then it changes and goes up. That's considered one turning point. Now notice if I put a negative in front of this x squared, the positive y's, which are the points above the x-axis, become negative. So this in turn goes this way. So instead of opening up, it opens down. So now we have a graph that looks like this. Okay, so a parabola coming down. So the thing I want you to notice here is when the exponent is even in this case, and the coefficient here is positive, the parabola of the graph went up at both ends. On the left and on the right, it opened up. When the exponent is even and I have a negative coefficient, it opens down. So on the far left it goes down, and the far right it goes down. Okay, so keep that in mind. One turning point. Now, if I consider the graph of, say, y equal x to the third, and I could make this x to the fifth or x to the seventh, keeping the exponent odd, and I would get a similar graph. But in this case it's x to the third, so if I were to plot some points or use a calculator or whatever and graph it, the graph would go something like this. It would pass. Okay, let me erase this. It would pass through the origin. So it goes something like this, and then it would go up. So again, x-intercept is at 0, 0, and a 0 of the graph would be x equal to 0. And notice that the exponent is odd, the coefficient is positive. On the far left the graph goes down, and the far right the graph goes up. This one has 0 turning points. 0 turning points. Because the graph doesn't change direction. It's going up. And here, when it gets to this point here, 0, 0, instead of coming down, it continues to go up. So this has no turning points or 0 turning points. Now if I put a negative in front of this, again, the negative y's become positive and the positives become negative, so this gets flipped around. So this then in turn comes down this way. Something like that. So let me take this top part off. So now the graph goes up on the far left and down on the far right. Okay, so now let's erase this and go through some properties. And again, what I'm going over here is just a supplement to what you're learning in your classroom. Okay, so this is just a supplement of things you will cover. So we have the polynomial. So again, in this polynomial, we're going to assume, unless stated otherwise, that these coefficients in front of the x's here are real numbers. They could be imaginary, complex numbers, but in this case, we're going to assume they're real numbers. And the other thing that is true is the exponent. The n is a non-negative integer. So the exponents can be 0, 1, 2, 3, 4, and so on. Okay. So I'm going to go through some statements. Some of these will refer, are a result of what I mentioned on the graphs that I drew. But here's what we have. These are some from theory of college algebra, some theorems from college algebra, and that's the maximum number of turning points of a graph of a polynomial is n minus 1. So in the first one that I did, the exponent was 2. That was even, so 2 minus 1 is 1. So y equal x to the second had 1 turning point. So remember, this says the maximum number of turning points is n minus 1. So what this means is if the degree is 2, the graph can have 1 or none turning points. Okay, so it follows then that if the graph has n minus 1 turning points, the degree of the polynomial is at least n. Okay, so if a graph if a polynomial is degree 3, like the second one I did, y equal x to the third, if it has degree 3, then 3 minus 1 is 2. So you would expect to have a maximum of 2 turning points. But keep in mind, that means a maximum. So that could be either 2, or 1, or 0. So in the one that I did, y equal x to the third, we had 0 or none. No turning points. The y-intercept of any polynomial is 0 a sub 0. Okay, so if you look at the function over here, replace the x by 0, and the last term doesn't have an x, so you're left with a sub 0. So the y-intercept would be 0, a sub 0. The polynomial has at most n zeros. Remember, the zeros correspond to the x-intercepts. Okay, so if a polynomial has degree 2, you would expect at most 2 zeros. Okay, at most, so it could have none. Okay, for example, if the parabola opens up and it's above the x-axis, then you're not going to have any zeros. Or if it opens down and the graph is below the x-axis, you're not going to have any zeros or x-intercepts. Number 5 states if x minus r to the n power is a factor of a polynomial, then the graph crosses the x-axis if m is odd, and it touches the x-axis, but does not cross if m is even, and r is said to be a 0 of multiplicity m. Okay, so in the first one that I did, I had y equal x to the second. Okay, y equal x to the second. The power was even, and you saw the parabola pass through 0, 0, or touched at 0, 0, and then it opened up. It didn't cross. Now in the second one, it was y equal x to the third, and we had a 0 again at the origin, but the graph crossed. So it went from below, and then across the point. So if the exponent is even at that particular 0 for that factor, it's going to touch the graph or the x-axis, but not touch. If it's odd at that particular 0, then it's going to cross. Okay, number 6, if the polynomial has odd degree, then the polynomial has at least one real 0. Okay, so if the polynomial has odd degree, then the polynomial has at least one real 0. Okay, again, the real zeros are associated with x-intercepts. So the graph is not going to have a real 0 if it doesn't touch. Okay, so if the degree is odd, we know it's going to touch because we said it goes up at one end and down at the other end, so it has to cross. Or if it's even, it goes up at both ends. So if it's a parabola, again, that's above the x-axis, opens up, or below the x-axis, opens down, it's not going to touch, so no real zeros. Now the other thing is the behavior of the graph is going to be dictated by the lead term. Okay, so that's what I did over here when I was doing the graphs of y equal x squared and y equal minus x squared, y equal x to the third, and y equal minus x to the third. I was trying to make that point that the graph is going to be determined by the highest degree term, which is the one that determines your degree. So over here then, and behavior. So here's what we know. If n is evened, okay, if n is even, and the coefficient is positive, then the graph goes up at both ends. Okay, so that's kind of similar to y equal x to the second. Now if n is evened and a sub n is negative, coefficient is negative, then the graph goes down at both ends. Okay, goes down at both ends. Now you could have several loops in between, but on the far left and the far right, it's going to go down. C, if n is odd, okay, so like that would be the example of y equal x to the third. If n is odd and the coefficient is positive, the graph goes down at the far left, as you saw in the graph that it did, and up on the far right. And of course, it's going to be just the opposite of that if the coefficient is negative, which is the next one. If n is odd and a sub n is negative, the graph goes up on the far left and down on the far right. Okay, so we're going to be using some of these concepts in the examples that I'm going to do, and some of these are going to carry over to the next video, which will involve the graphing of polynomials. I've done some graphs where I used the TI-83 plus graphing calculator. In the next video, I'm going to look at some graphs without using the graphing calculator. So let's look at some examples. And this will use some of the ideas I just went over. Determine which of the following are polynomials. For those that are polynomials, give the degree. Okay, so we said the coefficients can be any numbers. Normally they're going to be real numbers, but they could be complex. But the exponents have to be non-negative integers. So you can see here that the exponents here are 4, 3, 2, 1. And for the minus 6, the exponent there's no x, so that would be x to the 0. Okay, so this is a polynomial, and of course the highest degree term is the first one, so the degree is 4. Okay, look at number 2, and right away the second term has an exponent of 1/2. Okay, the exponents have to be non-negative integers, can't be fractions. So number 2 is not a polynomial. It's not a polynomial. So we don't give a degree. Number 3, exponents are 8, 1. The coefficients are radical 2, minus 3, and 9. No problem there. This is a polynomial. This is a polynomial. And the degree is 8. That's the highest power. Okay. Number 4. P of x equals, okay, 7x to the 6, no problem there, minus 8x, no problem there. But this 1 over x can be written as x to the negative 1. Okay, that can be written as x to the negative 1. So that one has a negative exponent, so it doesn't qualify as a polynomial. So number 4 is not a polynomial. Number 5. Look at the term, 7x to the 6, minus 9x to the second, no problem there, but the middle term has the 5th root of x, so that's the same thing as x to the 1/5. Okay, that's the same thing as x to the 1/5, because the nth root of x is equal to x to the 1 over n. So that tells me that that one is not a polynomial, because it has a fractional exponent. Okay, so then on the next one, it says discuss the behavior of the graphs for the polynomials in exercises 1 through 5. Okay, so we're going to discuss a brief discussion of the graphs for those that are polynomials. Okay, so the first one we said it's a polynomial. We said it's a polynomial. And it's even degree 4, and the coefficient is positive. So based on what we said then, the graph on the far left is going to go up, and on the far right it's going to go up. Okay, so we have something that goes like this, and over here goes up, and then in between you're going to have, since the degree is 4 since the degree is 4, you would expect to have at most 3 turning points. At most 3 turning points. Okay, that could mean 3, 2, 1, or none. Okay, and like I said, in the next video we'll look at actual graphs, so you'll see how many turning points you have, or you can do it in the graphing calculator. Okay, let's look at the next one. The next one we said was not a polynomial, so we won't discuss the graph there, because again, we're looking at just polynomials. Number 3, we said it's a polynomial, and it has degree 8, and it's even, and the coefficient is positive, so it's going to have the same situation. Okay, it's going to go up on the far left, up on the far right, and since the degree is 8, you can have as at most 7 turning points, 7 or less. Okay. The next one is not a polynomial, so nothing there. And of course the last one is not a polynomial, so nothing there. Okay, so I'm going to continue with polynomials in the next lesson, and it will be basically graphing polynomials without the graphing calculator. Like I said, I do have several videos on using the TI-83 Plus calculator. But that will conclude this video for now. If you have any suggestions, please post them, and if these help you, please subscribe to my channel, and we'll see you in the next video.